How are you?
Hey, doing good. I hope you're doing good.
Yeah, everything is good. Thank you.
Hey, people are already here on time. So I
Yeah.
think you can start sharing your screen.
Yeah. I think we can wait 1 or 2 minutes. People are still joining in.
Yep, that's true.
Yeah. Meanwhile, let me share my screen. We'll just wait for 1 more minute and then we'll start.
Yeah, sure.
Okay, I think we can start. First of all, good afternoon, everyone. Thank you for joining. So today we'll quickly do a recap of what we did yesterday and we'll pick it up from there. Let me start.
Sure. Thank you.
Okay, so we went from what was the purpose of Kubernetes. It was to host your application in an automated fashion so that you can deploy as many instances of your application as required and even enable the communication between different services. So we saw that if we create two pods, the communication is facilitated with the help of services between them. Then we moved ahead. We saw what are the features of Kubernetes, automated rollbacks and rollouts. Then we saw service discovery was one, self-healing was there. When we tried to delete one pod, it automatically recreated itself. Then there is horizontal scaling also. On behalf of the load, the pods will scale out automatically, and after some time, when the load gets decreased, the pods are going to scale in back. Then we saw the architecture of the Kubernetes. Like there are two nodes. One are the master nodes and then the worker nodes. On master nodes, you have the major components. Your Kube API server, which exposes your API. You have your etcd cluster, which is your key value store. Then you have your Kube scheduler, which decides which pod will be placed on which node. Then you have various offices which are combined together to form Kube Controller Manager, like there is pod replication controller, node replication controller, etc. Finally, we move to the worker nodes since we are dealing with containers. So we want everything to be container compatible. So we need to have Docker or Docker's equivalent to be installed everywhere. So it can be Docker or a Rocket or Cryo. Then we saw what's the function of a kubelet. Kubelet is like the captain on that node. It is basically responsible for deploying your pods. It can take in various spec files, various YAML files, those configurations that were taken and then deploy it. Finally, we saw the purpose of kubectl. It is always on the lookout for fetching various services in the cluster. So whenever a new service gets created, it creates appropriate IP table rules on the nodes so as to forward traffic to the backend pods. This we're going to see live in the demo part how this is done. So the next part is this was the theory part. Uh, One by one, we saw what component is doing which stuff. Finally, we were here. This is the part which we're going to cover now. So today, what I'm trying to cover is we will cover this theory part, and then we'll try to cover this objects in pod, like pod replica set deployment service. The idea is to cover till services. Okay, so we'll try to cover till services today. Let's see, and then we'll try to have some small demo also where we'll try to deploy a few objects on the Minikube cluster. Okay, cool. Yeah, so here we were. So the other few important components in Kubernetes is the first one is the DNS component. Now, whenever you see any website on the browser, you always type google.com or facebook.com, etc. You never type in the IP address. So the mechanism, I hope everyone knows what DNS is, but still, if the mechanism behind this IP address is that somewhere there is a DNS entry for that IP into a particular record, and that record will basically route it to that IP, and which it will give you the web page. For example, I have this in our project, Seagate project. What we use is we use DNS zones, private DNS zones provided by Azure. So here you can see over here we have these IP addresses, these websites basically. This is the name of the record set. So registration-api.live.seagate.com. So if I put this into my browser, let me copy it from there. Okay, so I'm getting this part. So this is the response which I'm getting. So this, how is this response coming? This is response is coming from the ingress. So from ingress, the IP which we got was this one, this IP, and we have created our DNS record for this URL against this IP. So whenever I'm hitting this URL, it points to this IP, and from this IP at the backend we have configured that this IP will route to a specific service. We'll obviously see these things in the demo. Just I'm giving you a high level overview how things are. Okay. So the next part is you can read this, the DNS part. I'm not going to read it because time is very limited. So the next thing is container resource monitoring. So there is one notable difference from Docker and Kubernetes. In case of Docker, your resources can consume as much CPU, as much memory they want, their containers. So the containers can keep on consuming, and it will after some time the process will get throttled. So your UI will get slow. All the processes which are functioning will get slow. That is the biggest drawback in case of Docker. But in case of Kubernetes, what you can do is you can define how much resource do you want it to consume. You can define memory and CPU request. That is one. And the second thing is, if I go to my Minikube cluster, let me go there. Let me see if it's running. So how to check if the Minikube is running? You do Minikube status. Okay, so it's running. Okay. Now let me see if I have any pods running. So how to check the pods is kubectl get pods. It's the same as doing Docker PS.
Sorry to interrupt you, Ikant. Actually, we are not getting the mail regarding the software. You said you have to send a mail for.
Yeah, I had a chat with Ankur today. Today he'll do it. Today after the training.
Okay, because due to the software lateness, we don't apply our hands-on for this.
Yeah, I understand. But in the meanwhile, since by the time you don't get this thing, what you can do is you can do Kubernetes. What was it called? Let me post this link in the chat. Yeah, okay. So you can sign up for this Katacoda. What it does is it gives you basically a playground to play for 15-20 minutes. It will have all Kubernetes etc. installed, and it will have the master node with it. Okay. So since by the time you don't get this email with the appropriate software details, you can use this. Okay. Let me put it in the chat. Okay, where is the chat for this? Okay, got it. So now, these pods are running. Okay. Now there is a command to check how much CPU utilization and memory utilization my pods are consuming. For that, we need to have a binary called metric server installed in it. I don't know we have it or not, but metric server is a binary which needs to be installed in your Kubernetes cluster. I don't think I'll be having it in this, but let me check. See, I did kubectl top pod command. And if I do kubectl top node command, it says metrics API not available. This is the metrics server which needs to be installed. Okay. Now, if I go to one of my office environments, my clusters, that will have it installed. Let me just quickly show you how it will look. Okay, I'm inside that only. So, okay, how I'm inside this particular VM. This is my office VM, and if I do get ns is for namespace. I'll tell you what a namespace is. Okay. Yeah. When I do kubectl top node command, it gives me how much CPU and how much memory is consumed by this node. I have two nodes over here. Okay, one is 01 and 00 and 01. And if I do kubectl get pods, let me see if I have any pods running. So I have this two pods running. Basically, you can ignore this one. And if I do kubectl top dot command, it shows me how much, since this is in running state, it will only show the one which is in the running state. So it will show that in CPU is consumed this much and memory is consumed this much. This is 3 millicores and this is 50 mi. Okay. So this is the difference. So the point which I was trying to highlight is this one: container resource monitoring. So with Kubernetes, you can monitor how much consumption is there. You can still monitor it with Docker, but with Docker, your resource can consume as much CPU and as much memory as it wants. But in case of Kubernetes, you can specify that you only want your pod to consume this much memory. If your pod goes more than the CPU and more than the memory, it will get killed, depending upon the setting that you have set. Okay. The third part is cluster level logging. Now, very important thing is you want to see what is happening with your containers, how are the logs getting generated, and how are you going to debug your application. That's the major part. That's the biggest concern you have in case of production environment. So now I'm back to my minikube cluster, which is my local environment. So if I again do kubectl git pods, I have these many pods running. Okay. Now, suppose something is wrong with this pod. It's possible that the UI is not coming up or something is there. So what I can do is kubectl logs. If I do logs, after logs, I need to pass in the container name. So the pod name basically. So this is the pod name. What you do is copy this and pass it, and you enter it. So it says app is listening on port number this. So everything is good. No issues in this. Okay. If suppose there is some issue at the back end that you have configured wrong environment variable, so you'll see a list of logs that this is wrong, this is wrong. Let's check the other thing. This one logs. Sorry about my voice. Actually, I have a throat infection. Okay. See, if I do this kubectl logs, yeah. So I do kubectl logs for this MongoDB pod. It says these are the things, and you can see everything looks good. And suppose if there would be some error, it will say the error log will be there, error is there, or warning is there, like that. But since you don't have these things, everything looks good. Now, this is in my system. The biggest challenge you have in a company is you need to flush these logs out to a central place, because your managers, the developers, they won't go inside the cluster and see the logs. Okay. For that, you have various tools. You have Datadog available with you. You have Prometheus is there, Grafana is there, but those are advanced level topics and not into scope of this 5-day course. So just letting you know that there are various tools which will flush out these logs and put it into a central part where everyone can see them. Okay. Prometheus is one, Grafana is one, Datadog is one. It depends how much an organization wants to pay and which tool do they support. Okay. Now let's move ahead. Now let's come to a very interesting part. Now we are going to actually deploy things into Kubernetes. You're going to see which objects are there into Kubernetes, and how are we going to go into the demo part. Okay. So the first thing is pod. Pod is the smallest unit that will be there in the Kubernetes. Similarly, you can say this is like a container in case of Docker. But how is a pod different than a container is that it's basically an abstraction over on top of that container. Similarly, you say that Python language, I don't know how many of you are familiar with Python. Python at the backend is written on C++. So Python is basically a wrapper built on C++ language. Okay. C plus or C sharp, I don't know, I might be wrong, but the idea is that it's a wrapper which is built on top of that language. Similarly, a pod you can say is a wrapper which is built on top of a container. Now the maximum containers that you can have inside a pod are 7. I'll show you how you can place those things, but the idea is pod is an abstraction on top of a container. Then you have the replica set, then you have the deployment. Now whenever you work with Kubernetes, this is the most important object that we are going to create. Okay, my bad, sorry. You will never create a pod. You will always create a deployment. So this is the hierarchy, okay? Your deployment will create a replica set, and that replica set will create a pod. Okay, I'm going to repeat again. Your deployment will create a replica set, and your replica set will create a pod. Now, why is this hierarchy? Okay, so suppose there is one application with me, the UI application is there. I want to deploy version 1.2 in that. And suppose, so for that, what I'll do is I'll write a deployment file. I'll put in the image details, environment variables, etc. Once that is done, I'll deploy that file. Once that file is deployed, the deployment will automatically create a replica set, which will automatically create a pod. Okay. Now, what is the function of the pod? Pod is the actual container which is doing all the task. What's the function of replica set? Replica set is basically a way to ensure that the number of pods keep on running. For example, yesterday I showed you that, let me do that again. So if you do ctl get pods. Now suppose if I delete this pod, okay. Now you'll see one unique thing that the name over here is MongoDB, and afterwards it's a alphanumeric string, okay, with numbers and alphabets. Now if I do kubectl delete pod, if I delete this pod, it will spin up another pod. But what will spin up another pod? How is it coming back up? That's how. So you see, a different pod is spinned up. It has a different name, and you can see that the age is 4 seconds. Now, what's the mechanism behind it? How is it coming up? That's what we're going to learn today. So the idea behind this is you have created a deployment file. If you see, if I do ls over here, not here. Okay. Now if I do ls over here, I have my deployment file inside this webapp.yaml and mongo.yaml. Okay. I have done this inside this deployment. Now this deployment file is creating a pod. It's creating a replica set which is creating a pod. Now let me show you that also. If I do kubectl get deployment, okay. Now let me go kubectl get replica set and do kubectl get pods. Okay. So this is the hierarchy. What I did is I only created the deployment. So that's why you see the deployment has proper names over here, MongoDB and web app deployment. Okay. Now this MongoDB deployment automatically created a replica set. That's why you have this MongoDB's hyphen this alphanumeric thing. Now see, you can see how the name is there. This is just one level name, and then you have this hyphen with this, and then you have this hyphen, again one more hyphen over here, right? So then your replica set monitors the pod. Now if I delete this pod, your replica set will see, okay, there was supposed to be one pod, and that pod is removed. So this thing will make sure this will send the information back to your kube controller manager. Kube controller manager will see, will have an office called pod replication controller. It will see, okay, there is one pod which is missing, so it will spin up another pod. Okay, that's how you do it. So this is how you deploy it, and this is how, in case of Kubernetes, you will have zero downtime, approximately zero downtime you have. Okay, I'll just show you properly how the things are, but that's the basic idea. that this is how things are. You create a deployment, deployment creates a replica set, and replica set will create a pod. Okay? Any doubts? Just a high level understanding will do. We'll see in depth later on. Okay? Okay, let's move ahead. The next thing is service. So I told you yesterday how pods communicate with each other. They do it via services. And there are various types of services in Kubernetes. So we're going to learn that in the next lectures. The next thing is config maps and secrets. These terms are almost same, but config maps are used to pass in environment variables to the containers, and secrets are used to pass in environment variables which are sensitive information. Okay, so in case of Docker, you guys might be aware about the Docker Compose file. In that Docker Compose, let me show you, maybe that will be a good idea. Okay, you see, this is one example of a Docker Compose file. You have your version and then you have the services. These services are basically the containers inside it. This is the name of the container, first one, and this is the second name of the container. Then you have your ports. Ports are, this is your host port and this is the container port. Then you have the volumes. Okay, it doesn't have the environment variables. I want to see one which has environment variables with it. Okay, so you see this one, this is the container name. This has an environment variable called db port, and this is the value of that. Now, how are you going to pass in these environment variables inside the pods or the containers? You can do it via the YAML files, the pod manifest files, or you can do it, create separate secrets and config maps and reference those secrets inside the pods. We are going to see it in the next part. I'm just giving you an overview what these config maps and secrets are. Then comes the namespaces. Now namespaces are very important, right? If suppose namespaces are basically a way to group things. Now, if I do this thing, I'm inside my minikube cluster. If I do kubectl get namespaces, there's a short form of namespace also. We can do kubectl get ms. Okay, so now currently we are working in a default namespace. If I do not kubectl, sorry, my bad. Get pods n. Let me do like this. Kubectl get pods. Now I'm fetching the pods which are present in my default namespace. Okay. Now if I want to see the pods which are present inside kube public namespace or kube system namespace, so what I can do is I can do kubectl get pods -n kube system. Now I told you yesterday that these are the pods. etc is there, API server is there, kube controller manager is there, kube scheduler is there. These are the pods which make your cluster work, right? These are the pods which are responsible for making the cluster work properly, and these are your master plane control plane pods. Now -n kube system. Now the next question should be, why do we have namespaces? What's the point of having namespaces? Okay, so the answer is, suppose if a new person in my team joins in my cluster, and I want to make sure that since that guy is pretty new, I don't want him to mess the things up in other namespaces. See, if I delete something over here, it will mess up the cluster, right? I don't want that particular guy to have access to this namespace. So there are ways to restrict access. So what you can do is you can create a role and role binding for that user, and you can give him only access to this particular namespace, default namespace, or you can give him read-only access to the entire cluster. These things can also be done. So basically, namespaces are logical way of doing separations in your cluster, so that it helps in increasing the efficiency, as well as it helps in ensuring that the users cannot delete things if those things are required, basically. Correct? That's the idea behind namespaces. Okay. So this is how you list down inside this kube system namespace. Now, if you do want to do list down the services, So what you can do is you can do kubectl get services hyphen n kube system, or you can do is services. There is a short form is there SVC. Yeah, we are obviously going to look into all these stuff. I'm just giving you an overview. Okay, now let's move ahead. Then you have your network policies, then you have persistent volumes and PVCs. These are basically advanced topics which we'll cover in the other lectures. Now let me move to the pod specification, and we'll try to create a pod today. Okay, we'll jump into the demo part after this. Sorry. Okay, now first of all, let's go to the theory quickly. So I told you the containers are getting abstracted with a layer called pods. So pods are basically abstraction over the containers. Pods are the smallest, most basic deployable objects in Kubernetes. A pod represents a single instance of a running process in your cluster. Okay, a pod, as in a pod, you can read this on your free time. I'll share the PPT today. So let's move ahead and let's try to learn this thing. Now this is the most basic simple syntax of pod. You can add in a lot of variety also over this, but this is the most simple syntax of a pod file. Okay, we try to create one pod also right now using the same thing. So let me open my Visual Studio Code. Let me create one directory first. Okay, I don't have any file, so I'll create the basic file. I'll call it pod1.yaml. Okay, so it can be YAML or it can be YML, up to you. Okay, so it can be this or it can be YML, whichever you prefer. Everything will work. I prefer YAML, so I'll do that. Now, YAML is yet another markup language. So it's pretty easy language. The only thing is you need to make sure that the indentation, it's proper should be there. Okay. So now the basic thing, I'll do it one by one. We'll do it together. So the first thing is.
Sorry
Yeah.
to interrupt you. Please, can you
No,
repeat
please,
once
go ahead.
again? Actually, my internet connectivity has been loose at that time.
Okay. At which place did you feel lost?
From pod theory of pod.
Okay, so actually theory of what we didn't go through. Let me just okay. So it was clear till right now, objects in Kubernetes.
Yeah.
Okay, so basically I skipped this theory. I just told everyone to read it on their own. So we'll just go through it quickly. As I told you that the pods are basically an abstraction over your containers. Pods are the smallest, most basic deployable objects in Kubernetes. A pod represents a single instance of a running process in your cluster. Okay, so the most basic process which we're running will be a pod one. And now we're going to see how we can deploy a pod.
So you can say that the pod is basically an image, or you can say that the container, which is when you deploy onto the Docker engine, then it runs an application.
Please repeat once again.
First of all, when for example, for pod is you say na pod is like a container. So the container is like a image. So if the image, so you are deploying the image or you are making the image at that step, at this step.
We are deploying the image. Okay, very good point. Let me just clear this one thing also with you. So when we're dealing with Kubernetes, right? So this part comes, okay, let me just give you a basic one thing. So I hope you guys are aware of the CI/CD cycle, although we are going a bit off topic, but let me give you this idea also, okay? So the first thing is you have your source code with you. From this source code, what you do is, in the source code, you need to create a Docker file. So in this Docker file, you'll add appropriate steps, all those there. Then what you will do is you will do Docker build. Okay, you'll do Docker build. From this Docker build, you'll get a Docker image, which will be an artifact of this particular source code. So you will get it as a Docker image. After getting a Docker image, what you will do is you will do a Docker tag to the appropriate naming convention. When you do is Docker push. So after pushing it, you can push it to Docker Hub, or you can push it to any private repository, whichever you have. Okay. Now, before dealing with Kubernetes, you need to make sure that these steps are carried out. Your image should be present inside the relevant Docker repository or any private repository. The next thing is you need to pull that image from the relevant Docker Hub or the private repository, and then you need to start to deploy it. So now the next step is you need to deploy your image, right? Deploy the image. Now what you can do is you can do various things with it. You can use Docker to deploy it, Docker run command, the container one, or you can do is you can use Kubernetes to deploy it. You can use OpenShift. You can use AKS cluster. You can use Azure Container Services. Then you have your AWS is there. AWS, your Kubernetes cluster running in AWS. KH. Then you can use Docker Swarm. Then you can use
these are basically what you can
orchestration tools. Orchestration tools. All of these are orchestration tools. Let me put it.
Orchestration tools.
Okay.
So the orchestration
Docker is the most basic one.
To deploy the Docker image on the Docker container itself.
It can be Docker, it can be any relevant container engine. It can be Cryo or it can be Mesos also. It can be container D, container CNTI, container D, or it can be Cryo. These are the, as of now, these are the alternatives to Docker. Okay, so but most probably you have Docker with Kubernetes. So Kubernetes is basically an orchestration tool which behind the scenes uses Docker. Okay, sounds fair? Okay. Now we're going to do is we're going to learn the basic syntax of how we're going to deploy the YAML file for a pod. We are going to create a manifest file for a pod. Okay. So ideally you should never do the way I'm doing it. You just need to go to the Kubernetes documentation. So this is basically your Bible. So everything is here. What you need to do is you just need to search out the things you want, and from here you can see whatever you want to do. So suppose if I want to see a pod, I'll search pod over here. Okay. So you'll get all the required things, and you'll get the required syntax over here as well, like this. You just need to copy it out and paste it and deploy it. Okay, but we'll do one by one. So the first thing we need to do is the API version. Okay, the next thing is bind. Next is metadata, and then you have finally your spec. Okay, now we'll talk one by one by each things. So so since you can say Kubernetes, everything works with APIs, right? Now in case of Kubernetes, you have multiple APIs to work with. Okay, in case of Kubernetes, you have multiple APIs to work with. So there is an API for everything. There is an API for taking the version. There is an API. There's an API called named API. There's an API called code API. Then there is an API called help, like this. So there are many APIs with Kubernetes. Okay. So the version over here is, if you are going to create a pod, it falls under a specific API, and then you need to pass in that API version over here. So you don't need to learn anything. You just go to this thing, go to Kubernetes documentation, go to this thing and check this. It's V1. So you copy it out and put it V1 over here. That's it. So notice that there should be a space after this. is basically a key value over here. Okay. So now I told you in case of YAML, the spacing is very important. So this API version and kind, all those four things should fall on the same space. Okay, you can't have kind to be the child of API version. No, it will give an error. Okay, we'll see these errors also. So the idea is that API version is the v1 because pod falls under that API. The next thing is kind. Kind should be what kind of object do you want to create. Here we are creating a pod, so the kind should be a pod. So P should be capital. You just need to copy this out. Okay. The next thing is your metadata. Now metadata is basically the additional information which your pod requires. Your pod should have can have a name, and then your pod can have many labels as you want. So if you are watching YouTube videos, everything is grouped on behalf of labels, right? You pass in some song you want to play, you pass in some value, automatically the search engine is going to fetch it from the label and is going to give you that value. So for example, if I have these pods running with me, right? To sit here, get pods. These pods must be having some labels or must not be having any labels. Okay, so what you can do is ctl get pods. If you do hyphen o wide means it you are expecting some additional information with it. Okay, so you get these additional information. See, you get IP address, node, nominated node, readiness gates, etc. Now if suppose you want to get the value of a label, okay, I think there is a way to do it. Hyphen uh, select, I'm forgetting it out. Okay, so anyway, I'll get back to you on that, but there's a way to fetch the labels which you have on the pods. Okay, so the next thing over here is under metadata. What you need to do is give a space, and the values which will fall under metadata is a dictionary. So you need to do two spaces. Under T, you need to give name and whatever value you want to pass. So over here, you just want to pass this name over here. We're not giving any labels as of now. Let me see in my PPT, I'll be giving the labels. Okay, we have labels over here. So we'll follow this thing only. So you can name whichever name do you want to name it. So let me name it, say, let me name this. I can name it whichever you want. So the next thing you want to pass it is the labels. So this labels is very important basically. So this labels is used to select. So whenever you're creating a deployment file, you're creating a service file. This label is a key which will help us to basically link that service file to this pod. Okay, so you can create whichever label you want, but let me see the spellings. But this label should be passed into the service file, which we are going to create soon. But let me show you this. So you can just do again two spaces like you did under metadata. So 1, 2. Okay, it should fall under B. Now any key value pair you can give. It's up to you. If I want to give, say, date, I can give 28. I can give month. It's up to you, whichever you want to create. Now, coming to this part, the spec section. This is the most important section for a YAML part. So what you need to pass in over here is you need to pass in the image name which you want to create. Okay. So under spec, what you do is you do two spaces. You need to put a hyphen over here like this. First of all, you need to give the containers, and then you need to put a hyphen. Let me see. Let me copy it from the Kubernetes documentation. Okay, so now under spec you have your containers. Okay, you have your containers, and this hyphen means it's a list. You can, if you want to have multiple containers, I told you can have 7 containers over here. So if I can do name as, say, nginx, let me put like this. I can have the same image if I want. It's up to me. So the maximum that I can do is I can go is 7. Okay. I'm not. Let's keep it simple as of now. Let me show you in one of the office environment. We have multiple pods running. So see, you have this. This is the pod name. Under this pod name, you have 3 by 3. 3 means there are 3 containers running inside this pod. Okay. But if you do this thing 1 by 1 means they have one container running inside this one pod. Okay. Let me now just we'll quickly deploy this and see. So image name my app hyphen container and busybox 1.28. Okay. And this container name can be anything. It's up to you. Which if you can want to put it the same, you can put it up to you. Okay. The next thing is let me just as of now remove this port. I'll tell you what this is later on. So this is the most basic YAML file which you can create. So you have your API version, kind, metadata, and spec. Okay. So my kind is I want to create a pod. API pod falls under this API version v1, and then under metadata you can provide the name and other details. You can even provide email, etc. if you want, but let's not do it. So the next thing is the labels. So your pod will get identified by these labels. So make sure these labels make sense, okay, as per your project. And the next thing is under spec, you have these containers. Now let's try to deploy this. Let's see if we have made any mistake or not. Now first of all, kubectl, let me remove all the things I have running. So let me do kubectl delete -f. One by one I can do it. Okay. So see, I did give it a get pods. It's in a terminating state. Means it's getting destroyed. Okay. kubectl get deployments. No resources found in the default namespace. If I do get SCC, okay, it's getting removed. When this will get sorry, this is the Kubernetes one. This is internal to Kubernetes, so this will always be there. Okay, I have not deployed the service. Let's just wait for a minute. Okay, everything is removed. Now what I want to do is I want to go inside this folder and I want to deploy this pod which I created. This is the pod I created. Okay, if I do kubectl apply -f, and I can pass in the file name or I can pass dot, up to you. Okay, dot means all the files inside this directory. Okay, very good. It gave an error. Now let's try to debug what error is there. It says unable to decode pod resource metadata object v1 reaching expects this thing or n but found 2. So what it says is it's trying to expect this thing code, but it got n, right? So you can see but found 2. Error found in 10 byte date. See, it wants your date to be in this quotes, but it's getting a number over here. Okay, so what you need to do is you pass in quotes to this. Okay, now let's try to again deploy this. Let's see. Okay, it's created now. So let's see if the pod is in the running state or not. Okay, it's in the container creating state. So what you can do is you can do kubectl get events. Okay, so if you do kubectl get events, it will show you that it first of all 26 minutes ago, then 9 seconds ago, you can say this backup container is there, failed container. So we'll try to see if it's getting scheduled or not. 22 seconds ago. Let's see. Okay, again, kubectl get pods, it says crash loop backoff. Again, it's an error. Let's try to debug it. What's the problem with this? Crash back loop means it's not getting the image properly. So what you will do is we can't. Okay, one more point over here. If you do kubectl get logs, and you pass in this pod name. Okay. So you won't be able to get any logs because your container is not in the running state. So to get the logs, you want your container in the running state. So what you need to do is you need to, if you want to debug this, you want to do kubectl describe pod, the pod name, and go inside this. Okay. It says, let's see one by one. Let's go from the top. Okay. So see, it's pulling the image from Docker. Okay. Image ID you can see is pulling it from Docker. State is getting crash back loop. It's possible that that image is not existing on the Docker hub. Okay, that is one of the reasons it is failing. Pulling image successfully pulled image container of already present on the machine. Back of restarting container. Okay, there is something wrong with that image. So what we'll do is, as of now, let me use the other image in the this one Nginx. Okay, so let me put in the container pod also. Let's try to now. If I want to delete this, so what I can do is I can do kubectl delete pod. That will be the declarative way of deleting it, but I want to delete it properly. So delete f -f dot. So that this is the imperative way of deleting things. Now, if you do kubectl dots, sorry, don't have anything over here. So there is one more flag which you can do. If you see, you need to input this command again and again to see if everything is working. So what you can do is there is a flag called watch. So you can do it opens a different terminal, and inside the terminal it waits for the status to change. See, it was in container creating state, it changed it to running state. Now if you do ctl get pods, you see that the pod is in the running state. Now if I want to see ctl logs of this pod, okay, so since this is in the running state, Nginx is not producing any logs. It happens with the tag depending upon the image this is. So since this is in the running state, it's not producing any logs to the user. If there will be some error state or this is stuck, something is wrong in the environment variables, it might produce some logs. It depends on the container to container image which you're using. Okay, so this is the basic idea of pod. Now the next question is, what do you mean by this container port? So let me do it with a Docker example. Docker. I hope you guys are familiar with Docker part fully. You don't get to work with Docker that much, so just so okay, hypothetically, so when you do Docker run, okay, you do -it something like that, -d, and then you pass in the port number colon another port number like this. This is how you do it, right? So this port is the host port, the port which you want to map it to the host, and this port is the port at which your container listens. Okay. Similarly, this is the port which you want to pass in to your YAML file. So if you go over here, see your Nginx is the image you're using. Nginx listen on the port container port 80. So that's why you need to pass in over the container port as this one 80. Okay. So this is your basic YAML definition or the syntax of how you create a YAML file for a pod. Okay. Any doubts? Guys, I hope you understood it.
Yes.
Okay, great. Sounds good. Okay, so let's move ahead. Let's cover config maps and secrets. Okay, and types of services. We'll do it. So the next thing is you need to pass in environment variables to your pods. Okay. So if you go to, again, you go to the documentation part, and if you do say env, okay. I want to give one example is where it's passing the environment variables directly. Okay, let me see 1 second. Okay, let's take example of this. Let's create another pod which has a environment variable. Okay, now let's go one by one. Let's see. Again, it has the API version which is v1. The kind is pod. Okay, metadata it's just giving the name as environment demo. Then the label it's giving its purpose is this one, demonstrate in envrs. Then inside the containers you have only one container, the spec section. In the container you have the name and you have the image. Now there is one noticeable difference between this image and the image which we used previously. Okay, let me put it over here. 5 मिनट आया, मैं बस खत्म कर रहा हूँ. Sorry guys, that's the perks of working from home. Okay, so
no issue, sir.
No sir, man, I'm only 27 years old. You're making me sound like an old man. Anyways, so okay, can anyone tell me what's the difference between this image and this image? Forget the tag, forget the this thing, but you see this is extra over here.
It is taking from Google containers.
Yes, correct. So if you don't pass in anything over here, by default it takes it from, it assumes that you are fetching the image from Docker Hub. But since it's passing these things, so it's purposely fetching that image from the Google Cloud Engine, whatever, Google repository, whatever you call it. Okay. Similarly, in our project, we are working with Azure Container Registry, ACR. So we are fetching that image from that ACR. Then inside the image name, you need to specify the entire image part. Let me show you that also. So that will be helpful to you guys. Okay, guys, can you please excuse me for 1 minute? Again, my grandmother is there. I need to go see him for 1 minute. Sorry, guys. I'll be back.
आपने इसका कॉलम बनाया, उसमें आपका ऑर्डर नंबर डिमांड क्लास आता है, ठीक है। अब आप क्या करते हो, उस डिमांड क्लास को हटा देते हो और आप ना यहाँ से सर्च करके कुछ भी डाल देते हो। ओके, जैसे ही आप सर्च करके डिमांड क्लास डालोगे, ये ले लेगा डिमांड क्लास। लेकिन आप जब दोबारा मास्टर कोड डालोगे प्रीव्यू कोड पे, तो कॉलम वाली लिंक वहां से हट जाएगी, मतलब मास्टर कोड में कॉलम दिखना ही बंद हो जाएगा। ये अभी
और जो ऑर्डर नंबर है प्रीव्यू वाला, वो ऑर्डर नंबर यहाँ सर्च में डालते हो तो आता है?
और सर ऐसे कभी सर्च करके देखा नहीं, लेकिन आ जाएगा।
देखो एक बार।
सर ये स्प्रिंग किसने शेयर किया है? वेबसी ने किया है क्या?
मतलब ये कहीं ना कहीं किसी व्यू से आता होगा ना, उस व्यू में मतलब टेबल में आता होगा।
एक काम कर लो, इस कोड को कॉपी करो पहले। हो गया कॉपी? अब एक काम करो, इस पे ऑर्डर समरी पे जाओ, ऑर्डर समरी पे नीचे आओ, ये डिमांड क्लास कॉपी करो और इस सर्च आइकन में जाके सर्च करो सेव।
ये ईआरपी ऑर्डर नंबर है?
हाँ सर ये ऑर्डर नंबर है।
ये तो नहीं आ रहा ना?
नहीं आ रहा है सर।
हाँ तो ये छोड़ दो, ये नहीं आ रहा। और अगर तुम यही डाल दोगे तो ईआरपी में फेल हो जाता है बोल रहे हो?
सर ईआरपी में अभी आज की डेट में फेल हो जा रहा है, इसीलिए हमें ईआरपी
इसको छोड़ो, इसको छोड़ो, प्रोडक्शन का कोई कोड खोलो। प्रोडक्शन में भी देखा था सर, यही हो रहा है।
प्रोडक्शन में भी हमने टेस्ट किया था, सेम हो रहा है कि अगर हम सर्च करके कोई और डाल देते हैं ना तो उसका लिंकेज खत्म हो जा रहा है।
समझ गया मैं, वो समझ गया। अभी इसमें जाओ प्रोडक्शन पे, इसमें कोई कोड खोलो पीवीओ वाला और उसका कॉल ऑफ देखो। बस खाली सर्च का, हमें एडिट नहीं करना है, खाली हमें व्यू करना है।
मैं पिंग करती हूँ जैसे आपको एक प्रोडक्शन कोड जो कल हमने किया था, लेकिन वो डिलीट मार दिया था मैंने। चलो आप सर्च कर लो।
आप सर्च कर लो ना, कोई भी पीवीओ वाला सर्च कर लो, बस उसका ऑर्डर नंबर हमें कॉल ऑफ में सर्च करना है, नया कोड क्रिएट करके, और कुछ नहीं करना। पीवीओ वाला मेरी डाल दो SS185105।
9 को था आपने
5105। जी मेरा एक्सेस कैसे रिवोक हो गया? 185105 चल रहा है मेरा, देखता हूँ चला के चल रहा है। हाँ मेरे ही हटा दिया इन्होंने।
लिप्सी लेको का डाल सकते हो, हो जाएगा LM250 क्या है आगे चेक करना पड़ेगा। मैंने डाल दिया।
ये प्रोडक्शन से लेना क्या ना, ये वाली साइड। बस हम ये चेक कर रहे हैं कि जो आप सोच रहे हो कि पीवीओ का ऑर्डर नंबर वैलिड क्लास डिमांड क्लास होती है, वो सही है।
आई थी आपको
चेक करना है।
तो आपने कैसे करी पोटी? आप क्यों भैया मेहनत कर रहे हैं, आवाज नहीं कर रहे?
हम ये मतलब ये प्रोडक्शन पे डालते हैं वहाँ पे यूजर पीवीओ का ऑर्डर डालते होते हैं तो अभी तक
हाय टीम,
हो सकता है ना टेस्ट पे बना नहीं है वाला डिमांड क्लास।
Prasanjit here. Harpreet will back within 5 minutes. Guys, wait. Then he will join. Otherwise, you will continue the other topic in next call.
Okay.
Hi team, sorry I'm back. You guys are there? Hello.
Okay, Harpreet is back.
You guys are there? Hello.
Yes.
Yes.
Yes, sir.
Yeah.
One second. Yeah, okay. Sorry about that. I'm very sorry. Let's quickly cover this. Okay, I wanted to show you that how the ACR thing will look. We'll extend it today for 5-10 minutes. I hope everyone is okay with that.
Yes.
Okay, great. Thank you. So you go inside any tag and you'll see this is the name. Okay. So this is how it's going to pull. See, this is the name of the ACR, and this is since Azure, so it has .io in it. Okay. then it has the repo name, and then this is the name of the image. Similarly, this is the repo name, and this is the name of the image over here. Okay, image colon the tag number. Now you should ask the next question, that how are we getting logged in inside this IO part? Means how are we getting logged in inside this Azure and Docker Hub or this GC Google thing? So to answer that question, there is a thing called image pool secrets. Okay, I don't want to go inside that because that's an advanced topic, but there's a thing called image pool secrets. You put in your credentials over there. You do Docker login, etc. You put all the credentials over here. Okay, the credentials is there, and you create a secret out of it, and that secret is passed through that pod specification file. Okay, now since this is a public one, so you don't need to create a secret. For example, if you go here, you are fetching this image from Docker Hub. This is a public Docker Hub image, right? So you don't need to pass in any credentials over here. Similarly, if you go to this, you are passing, what do you call it? This is a public image, right? So you don't need to pass in any image pool secret over here. But if this was a private repository, which will be there in your case, in your production setup, your environments, then you need to pass in that image pool secret. Okay, that's an advanced topic, so you're not going to cover. Just letting you guys know. Now the next thing is I want to we covered till here, right? We covered till containers, name, image. The next thing is the environment. Now this image requires environment variables, two environment variables basically. The name of the environment variables is demo greeting and demo farewell. Now, but there are two ways of doing this. What you can do is you can hard code these values. Okay, where is that? Yeah. So you can hard code these values inside this Docker image part. Okay, hard code it. That is one approach. And the second approach is you pass in as you pass them as environment variables in the YAML files. So which approach should you guys take? Question for you all. Either you can pass in, you can hard code the this environment variables inside your Docker image, or you can pass in them as environment variables in your YAML files. So which approach would you guys prefer? If I tomorrow, if suppose I'm your manager and I ask you to create a cluster with these sets of requirements and these sets of pods, so I have these environment variables which needs to be passed. So which approach will you guys take?
YAML file.
Correct. YAML file. So the idea is you never hard code these variables inside your image, because suppose if you want to change those variables, you need to go inside the image again, rebuild the image, change it out, and then deploy it again. But if you have them inside this YAML file, it becomes very easy. Now suppose if the first environment variable over here is hello from the environment, I want to change it. I can change it directly, hello from Akirat. I can put this, it's up to me, right? So, but there is again one drawback with this approach. Now suppose in my production setup, I'll have hundreds of pods. Hundreds of pods are there, then there will be hundreds of YAML files. Okay, again it will become tedious to go inside each pod and pass in the environment variables. So that's how a concept of config map is introduced. But let me first of all deploy this thing. Let me show you how it is deployed. What you do is kubectl apply ifnf. Always use this approach. kubectl apply, do it by a file, right? Don't do it by imperative commands. There are few commands which will also create a pod with just one-liner commands. Okay, those are called imperative commands. Those are easy for cracking the exam purposes, where you just want to do it quickly. But in case of a production setup where you'll be working with an environment, you'll always have these files, and these files will be checked into your source code repository, GitHub or any Bitbucket, etc., whichever one you guys are using. Okay, so if you do this, kubectl apply -fpod2. Okay, it says this env var demo.credit, and how is this name getting fetched? It's getting this name from here. Okay, so you do this kubectl get pods. It's in the container getting state. So now you want to watch the status of this. You can watch it. It will poll the status after every 2 seconds. Okay, you don't need to enter that same command again and again. So this is how you can watch it out. Let's wait for some time. Let's see if it's getting created or not. It's a from this GC Google thing, na. It might take time, or it might even give us an error also. Okay, good. It's in the running state. So what you do is kubectl reports. Now I want to see the logs. Let's try if it is flushing out the logs or not. No, it's not giving any logs also. Anyways, kubectl logs. Now, if you want to see if these environment variables are set properly or not, so this is a command called kubectl describe pod. Go inside this. So it gives you an output that this is what the Kubernetes have created it. So let me go one by one. Now it says, see, name we specified. We didn't specify any namespace over here. By the way, we can specify we can specify namespace over here also. I can put it in cube system namespace, whichever namespace I want. Okay, since we don't put it out, so it's going to take the default namespace. The node, it has placed the pod on that node, the minikube one. Then the start time, these things are added by Kubernetes automatically. Okay, it's giving the IP of the pod. Then inside the containers, this is the name of the container. The container ID is this one. Image is this one. So the next thing is, see under environment, you'll see the environment variables. Okay. Demo greeting, hello from Harkirat, such as sweet sorrow, demo farewell. Okay. So this is the environment variables which were passed. The next thing is volumes, we're not as not bothered. So the next, see, you see the events over here. Successfully assigned this thing to minikube, pulling image, then pull image is successful, created the container, started the container. And see, these processes are done by kubelet. I told you, right? And successfully assigned, I told you that scheduler is the one which picks the pod. It will place that this pod will be placed on this node. So this is done by scheduler. It says successfully assigned this to minikube. He has selected, the scheduler selected that this pod will be placed on this node. But the deployment part, created the container, started the container, is done by kubelet. Okay, this is a very common interview question. They will ask you that scheduler will deploy the image or kubelet will do, and many people will do say scheduler will do it, but scheduler just selects the image. Okay, selects that which pod will be placed on which node. Now, so now in a production setup, you'll have hundreds of pod, you'll have hundreds of files. Now this becomes difficult. So what you can do is you can create another file. You can call it config map. Okay. Now you can create, it's a key value store. You can pass in all the environment variables one by one. And all these environment variables will be referred by these pods. So you just need to maintain it on one place. And the reference will be taken by all the pods. Okay, how is that is done? We'll see it right now. So let me say, okay, sorry. So we can quickly read it out. A config map is an API object used to store non-confidential data in key value pairs. Pods can consume config maps as environment variables, command documents, or configuration files in a volume. You can ignore this part, config files in a volume. This is an advanced topic. This is like if you want to inject one certificate inside that environment variable as a config map. That is an advanced topic. As of now, we are just concerned about environment variables. Okay. Then a config map allows you to decouple environment specific configuration from your container images, so as your application are easily portable. Right? If you have one file in which you're maintaining all the key value pairs, and you can do this portable part very easily. The next thing is the secrets. Now secrets are same as config maps. The only difference is there that this time the data is confidential. For example, if you have your Mongo cluster running, the Mongo password is a very confidential thing, right? You can't put it into directly in the config map. And these files you check into your source code repository. Now suppose if you check in the config map value, if you check in like password equals to say local@219. Now this is a very sensitive information. You can't check in like this directly to the source code management tool. Some people are doing it. In my previous company, we used to do it. That is a very sad thing. But anyway, we didn't have any approach, but we were doing it like that. But never ever do these kinds of things. So what you do is, in case of secrets, there's a thing called utility is there base 64. You encode those things and pass them as a utility. So for example, what you do is, so there is a this thing is there, right? Password is there, joker@219. So what you can do is dash n base 64. Now you'll pass this thing. You'll this is how you encode it. Sorry, and you'll pass this value over here. Okay, in the secret part. Let me show you over here. I start from current slide. Sorry. So for secrets, okay, first of all, let me show you the config map part. So on the left side, you'll have the config map, right? So similarly, again, you want to create something, it will be API version, kind, metadata, and in case of spec, here it will be data. Okay, so your API version is v1. It has the same version as the pod. The kind name is the name of the config map, and the metadata is name of that config map. This name can be up to you, whichever you want to configure. Then under data, these are the environment variables which is required by your application. Okay, you can pass in these variables, whichever variables you want to pass. Now inside the pod specification, inside the environment variables, you were passing in like name and value, right? But you'll pass the name. Here you'll be do value from. You'll fetch the value. Okay, sorry. Yeah, you'll fetch the value from that config map key reference. This one. So the name of there can be multiple config maps in your source code repository. So you need to pass in the name. The name will be game demo. This name should be matching with this one. And the key which you want to fetch is this key. If you fetch this key, it will give you value 3. This 3 value will be stored inside this environment variable, which is the player initial lives. Similarly, you come down, the name of the environment variable is this one. Its value from, you're fetching it from the config map key reference. The name is this one, game demo, and the value is, this is a key. So this key will give you this value, and this value will be placed inside this environment variable. I know it's a lot to take, but this is how you can reference this config map inside a pod. Okay, we'll see this demo tomorrow for this one. Tomorrow, maybe when we do the demo at the end of the day, with all these things. So this is how you pass in the config maps. Now suppose this instead of config maps, you have secrets, which are very sensitive data. So you'd pass them like this. So first of all, you have these values. Username is admin, and your password is, suppose this is a password. You need to base 64 encode it. You'll encode it into base 64. It will give these values, and you'll pass in these values over here. Now you need to make sure that the secret of type should be opaque. Opaque is the most general use secret. It is used for passing in the data like this. There are various types of secret. You can see the documentation. There are around, I think, 10, 12 types of secrets which you can create. But for the purposes of this PPT and all, we'll just look into the most basic one, which is the opaque one. Now, similarly, these secret needs to be referenced inside my pod. So again, API version v1 kind is pod. Name, this is the one, and then under this name, under environment variable, you have this name is secret username. Now where are you fetching the value? You're fetching the value from a secret whose name is my secret. So this my secret name should match, and the key here is username, right? So similarly, name is this secret password and the key is the password. Now in a production setup, passing into these things, this is also not the correct way, but just to get you started, this is how you do it with secrets. For managing secrets, there are various different types of tools are there. There is HashiCorp Vault, there is vaults inside Azure, there is vault inside AWS, etc. You use these vaults to consume your secrets. You never pass in like this, but this is a better secure way than passing it like this in the config map. Okay. So just this is one better approach to pass in the secrets like this rather than passing it like a config map. That is just one approach. But the official way of doing it in a production setup is using a third-party tool to manage your secrets. It can be HashiCorp Vault, it can be Azure Key Vault, or AWS Key Vault, whichever cloud environment that you're using. Okay. So we'll try to stop over here. Any doubts? I'll ask Ankur to send this PPT so that you guys can have a look, and I'll send you the link in which you can do your hands-on. Okay. I think it's pretty late over here. We need to work also. Okay, guys. Thank you so much for listening. We'll catch up tomorrow. Thank you.
Thank you.
Thank you, sir.
Thank you. Bye
Bye,
bye. Take
everyone.
care.
Thank you.